we are having the union operations, we are having a couple of doubts. Okay, so we'll see how it will work today, and I will show a little bit. Of course, I will explain you the with reference to the relational algebra. What is the meaning of union, intersect, except, or that operations or difference operations? Okay, the terminology may be different from the uh, relational algebra and SQL. No, don't worry, but everything is same. Clear? So when come to the relational SQL, okay, uh, we are having a set of set manipulation operation like uh, set operations in the relational algebra. We are also having the specific set related, some more set related operation apart from the set manipulation operations. The basic set operations, okay, in the SQL is union, intersect, and except. What this union will do is, whenever we are identifying the two different sets of results of same type, the same type of results can be combined together into single output that can be performed using the union. Why you are using this? Output is same, but conditions are different. Output is same, but conditions are different. Okay, so from the different conditions we are getting the same type of result, and then we are combined together into the single result. That is the meaning of union. Okay, the number of fields and data types in the results must be same whenever we are using the union operations. Okay, when come to the intersect, similarly we are identifying two different set of results. Generally we are once again here also we are taking the same type of outputs, but here we are observing the common results between the two different type of results, common things between the two different set of results. Okay, common values. The common values we can identify as intersect. Similarly, the except is operation where we use we want to get the all result from the first result set, but we want to result a portion of values which are present in the second result. Okay, if something is common in the second result set, we'll remove that from the first result. Except. Okay, so we'll try to execute today and tomorrow's class. Before the particular thing, 99% I will complete the union operation today, and I will see the remaining operations in the tomorrow. Okay, because apart from this particular thing, I want to show something else also, the previous results also. Okay, apart from this particular thing, we are using the in operator. We want to check against a set of values. The condition must present in any one of these particular values we are presenting in the in. The results must present in one of the values in the given set. That is the result we use in. Any means we can combine whatever the result we are getting against any value in the given set. That is the reason we can call it as a set operators. Okay. Otherwise, sometimes we want to check whatever the result we are getting. The result is going to be true for all values provided in the given set. Then we can use all. Okay. So we'll identify these particular operations apart from the like all or any. We can use like we can use exit. Exit is the thing. Whatever the based on the given condition, it must produce some result. It should not produce. It should not produce empty result. It should not present empty result. Okay. Empty result కాకుండా ఏదో ఒక రిజల్ట్ వచ్చినా ఎగ్జిట్ ట్రూ అవుతుంది. Clear? These operators we are going to see. Apart from this particular thing, this in or exits even can be prefixed by not operation also, not in. నాట్ ఎగ్జిస్ట్ అంటే అటువంటి రిజల్ట్ ఏమీ లేకపోతే, ఇచ్చిన వాల్యూ దేంట్లోనూ లేకపోతే, ఓకే, we can get some other result. Clear? Right. So for it we'll identify today one query only. Okay, we'll compare our previous operations against this one and only common value, and the remaining thing we'll see in the tomorrow's class. Okay, I will try to cover the theory, and if possible, if the time is there, then the practical aspect I will explain you in the next class. Okay, so first of all we will try to complete this particular query. Okay, but only thing is, before going with this particular query, I want to show something else. I want to elaborate. So we want to say, for example, we want to identify the sailors who reserved a red board or a green board or red or green board. Okay, the possibilities, all these possibilities we need to identify today. Then we'll apply union operation. Before this particular thing, in the last class, apart from the two queries result I shown to you, we discussed a couple of other facts. Okay, what is the basic query? Okay, what it do when select with the select operations, what it do with reference to the from class, what it do against the where class. Okay, so today we'll try to identify those things also, then we'll go with the other one. Okay, so first of all we'll see a small query in our SQL command. We identified that I shown you yesterday, that tables whatever we created. Once again we'll see what is the query. Select star from sailors, we'll use, then we'll use the remaining thing. So we are having the 9 rows. Then we'll see boards. We are having the 4 rows. Then we see reserves. Okay, 6 rows. Clear? So 9 rows are available in the first table. 4 rows are available in the second table. 6 rows are available in the third table. Okay, so try to identify what is the multiplication of 9 into 4, 9 into 4 into 6. Okay, based on this particular thing, we are going to get our results. Okay, so first of all we'll see a small query. If the query is executed, what happens? It is applying the project operator, applying the select operator, then applying the Cartesian product also. If this particular query is identifying name of sailors who reserved a red board. Be careful. This particular query is indicating only name of the sailors who reserved red board. Okay, we'll observe after identifying the select operators, project operators, all the necessary conditions in the selection or projection. Output, we are getting only 2 rows. Okay, but what happens, I told you, first it is creating the Cartesian product. First it is producing Cartesian product. We'll see what happens if it is applying the Cartesian product only without where class. Okay, now here we are using 3 tables. Okay, getting the star, not applying the projection operation also. Okay, it is simply we are using 3 tables. What I told you, the Cartesian product, each and every row in the first table will be joined with the second table. Cross multiplication it will do 9 into 4. The 9 into 4 becomes 54 rows will be created. Then the 54 rows will be joined with all 6 rows in the third table called as reserved. Okay, so it is producing a bigger table where it is number of rows are nothing but 9 into 4 into 6. Okay, 9 into 4 into 6. It is joining each and every table in one with each and every row in the other table. But only thing is whether you are using any conditions or not. If you are using the natural join, what happens? If you are not using the natural join, what happens? Okay, once again we'll apply. But basically what it is doing, it is joining each and every row in one table with each and every row in another table. But only thing is, if it is having any common fields, based on the common fields, it is joining the tables. Clear? So we call it as a natural join also. So based on this particular join, it is created 216 rows. It is created 216 rows. Okay, that is the meaning of Cartesian product. In the Cartesian product, what it is did? It is joined each and every row with each and every row in the other table. Okay, so because it is having the number of rows are more. Okay, we are not getting the header also. Once again, we'll see all possibilities. Now, previously I joined all 3 rows. Now I am joining only 2 tables. Okay. So if you are joined the 2 rows, automatically each and every row in first table is joined with each and every row in the second table. What is the thing here? First table is containing the sailors information. Second table is containing reserves information. Okay, 9 sailors with 9 rows in the sailors table with 6 rows in the reservation table. Okay, that is the reason we are getting this particular thing. Okay, instead of this particular thing, we will see what happens if you join both tables B. Okay, with the reserves table R. Previously, sailor table is joined with the reserves table. Now I am joining sailors table with boats table. Okay, it is created 9 into 4, 36 rows. Okay, later because both are having SID and a sailor ID, these 36 rows are joined with okay the reserves the 6 rows. That is the reason it is created. It is created 216 rows. It is created 216 rows. This is a blind Cartesian product. 36 into 6, 216. Clear? Here what happens once again, clearly it is indicating all rows in the first table, all columns in the first table is joined with all columns in the second table. The row number 1 in the first table is having SID1, S name, rating and age. Identify this particular is repeated because in the second table we are having the 4 rows. The 4. This first row is joined with each and every row in the second table. That is the reason it is becoming into the 4 rows. Then the second row in the first table joined with each and every row in the second table. Be careful. All these are repeating. This 4 once again we got once again here. Once again these 4 rows are repeated once again. Once again the 4 rows are repeated once again. This repetition has been taken place 9 times. This repetition has been taken 9 times with each and every row in the sailors table. That is the meaning of Cartesian product or cross product. Okay. So the thing is now today we are comparing this cross product with the union operation. This cross product with the union operation. So by default what is happening? What are the tables we are mentioning in the from class? It is creating a Cartesian product 9 into 4 into 6. Okay, right, total 216. total 216. That is the meaning of Cartesian product that we are getting from that instead of this one projection also. From the Cartesian product, we'll see projection operation also. What projection you want from the Euler's table? From the Euler's table, you want S name. You want S name. Previously, I used the star. Now I am using this one. Okay. So now it is created 36 rows, but extracted only S name column. But extracted only S column name. If you are using the distinct keywords, automatically duplicate names will be eliminated. Duplicates names will be eliminated. Okay, right. What was our original question now? We want to find the names of sailors who reserved a red boat or green boat. Okay. First of all, individually we'll see what is the thing we are getting through if you reserves only red boat, or we are execute a separate query for executing what you are going to get when you are executing green boat. Okay, red boat separately, then green boat separately, then we'll identify the other thing. Okay, right. Okay, we are getting the S name only, but we are using the previous Cartesian product also. But in addition with the select operation, project operation, now we are using in addition with the Cartesian product and the project operation, we are using select operation also. Select operation is based on the where class. Based on the where class. Previously in the previous whatever the executions, first I shown you Cartesian product. Then I shown you the select projection operation. Now I am showing you the including this those two operations, select operation also, applying the condition also. What this particular condition is showing? Additional thing is where color is equal to red. Okay, but before doing this particular thing, I am also verifying what happens S dot SID equal to R dot SID and R dot BID is equal to B dot BID. Okay, so we also do this phase manner. Before applying this particular thing, we'll apply the where SID S dot SID is equal to R dot SID. First we'll see that particular thing. Okay, now the previous the result was now reduced to 24 rows. The 24 rows is indicating only when the previous SID S dot SID equal to R dot SID. Okay, the previous 36 rows now reduced to 24 rows. Okay, now it is taking a common field where Euler SID is equal to that Euler SID if and only present in the R dot SID. Those who are not reserved any board, okay, that value is automatically removed from the result. Okay, it contains only those Euler names who reserved a board. Okay, remaining values are automatically removed. Clear? Right. Now we'll little bit expand once again. Okay, where because the previous query is combined based on the condition SID and Euler's table and reserves table only. Now we'll see whether the reserved value is present in the boat ID also. Okay, whether the reserved boat, the reservation, whatever the number we identified, whether the same SID and boat ID is present in the boat table also. Automatically reserve table. Okay, it filters once again. Not only the Sailors table that the Sailor ID identifies in the boats table, okay, that means a reservoir table, but also should be available in the boats table. The same boat ID, okay, as not only SID should present, we are having the 4 different boat IDs also. In the from the 4 different boats, we are interested only those boats are reserved by these sailors. Those boats which are reserved by these sailors only. Okay, that is the reason we included one more condition where reserves.bid is in the b.bid. Okay, after applying the second condition, automatically 24 rows becomes 6 rows. Okay. Okay. Now, not only that boat ID should present here, but also we are interested in one more condition. We are interested in one more condition. What is this condition? That boat color is also should be red. That boat color should also be red. Okay. Previously, we identified whether any sailor is reserved, any sailor is reserved, any boat or not. So the sailor's information is present in the reservation table or not. Then we also identified only those boats which are reserved in the reserve table. Okay, so the 24 reserved becomes into the 6 rows. Now we are applying. We are interested only red boats, not all boats. Now we are applying this condition also. After applying this particular condition, the number of boats is becoming, the sailor names becoming only 2. So only these 2 sailors reserved a boat. Only these 2 sailors reserved a boat where the color is equal to red. Where the color is equal to red. Okay. So this is the way we are executing. First, we are creating the Cartesian product. Then we are applying the where condition. From the where condition, we are applying the project condition. Be careful. I shown you first Cartesian product, then project, then where class. But the operations are first Cartesian product, then where class, then project operation. Okay, right. Now, what is our required thing? We want the sailors who reserve red or green boat. Okay, we identified who reserved the red boat. Now we will see who reserved the green boat. The operations are same. Okay, right. So the green boat are reserved by 2 people. Red boat are reserved by 2 people. But of these 2, the second list is deviating from the first list. Only one name is common, one name is different. One name is common and one name is different. Okay. Whenever we are applying, those who reserved red board, we got 2 names. Similarly, when we are finding who reserved the green board, after applying the Cartesian product, then where class, then select class. Okay, we are getting two results. But of the two results, one is common, one is different. We want to find out now either a red boat or green boat. Okay, if you are combining, automatically these 2 results will be clubbed together. Okay, of those, of course, one name may be repeating. We'll see what happens that particular operation. Okay, whenever you want to find out whether he reserved a red boat or a green boat, okay, look, the previous whatever I've given you, the queries are as it is repeating. Select S name from Silas, reserves or ports B. Okay, where class till the color is equal to red is same as it is in the above one. But here using the union operator, union keyword, after union keyword, I repeated the second query. Before this union, I typed all values from the first query. After this union, I repeated all from the second query. That means these two queries are joined using the keyword union, nothing else. Okay? If you are using this particular thing, automatically the two previous sets are combined together. Automatically the two previous result sets are combined together and eliminated duplicate values. Okay, now here this union operation is now by this particular time you identified this union operation is different from the previous Cartesian product. The Cartesian products joined the two sets of columns together, whereas the union operation joined two result sets together, where the condition is the two result sets must have same set of values and same data types, or same number of columns with same data types. Okay, so the thing is the result one is automatically combined with the result two and eliminated duplicate values. That is the meaning of union operation. Why you are using this union operation? Okay, the same thing can also be done by one more operation. Okay, for simplicity we made result 1 and result 2 and join these two results together with a single one. Okay, now I will show you one more set of operation where you can use these two operations together. The same result can be produced using the conditions. Okay, previously simply I made as color is equal to red. Okay, but I can reproduce the same thing using the b dot color is equal to red or b dot color is equal to green. Okay, which is producing four values where the name is repeated. Okay, where the name is repeated. It is using this particular query, the above query is applying the condition whether the color is equal to red or color is equal to green with each and every row in the Cartesian product, or whatever the row satisfied, the rows are included, and filtered is the column value where the name is repeated, the one name is repeated twice. Okay, when you are using the union operation, the condition is very simple, but only thing is repeated twice. The SQL query is maybe a little bit lengthy, but condition representing the each and every condition is simple. Complexity is reduced, but we type it twice and join the union keyword. But what is the advantage if you are seeing the verifying these two outputs? In the union operator, automatically eliminated duplicate values. The union operator automatically eliminated duplicate values where the same output we are producing using a complex query is not eliminated the duplicate values. If you want to eliminate the duplicate values, once again you need to use distinct keyword. That is the set operations union. Okay, if you are having any doubt you can ask me. Once again with reference to the Cartesian product, today I showed you what is the meaning of Cartesian product, what happens when you are applying the where class, what happens by applying the column values in the select class, and comparing with the union operator. Okay, this is some advantages of the union operation. The union operation is always simple. The complex you need not produce. Of course, it is whatever I am showing. It looks simple, but sometimes we use complex queries, complex conditions Instead of simple say red or green, we can use the complex queries, but producing the same type of output. Producing same type of output. If the output is same type, we can simply combine using the union operation. Automatically the union operation eliminates the duplicate values. Okay, right. So if you are having any doubts, you can ask me. The remaining two operations will produce in the tomorrow's class. Okay, I will share these things also maybe today or tomorrow. Right. Be careful, inform each and everybody, try to join as many as possible. Okay, today the length is a little bit low. Okay, so if you are identifying, if you are in the class, automatically, okay, that practical, because you are unable to maybe execute the same thing on the systems. At least I will show the outputs. I will share the outputs to you. Okay, right.